Hello again and welcome back. In this lesson, I'm going to show you some raster display options in ArcGIS. Specifically, we'll look at turning digital elevation models into hill shades just visually in your map document without using a geoprocessing tool, and hypsometric tinting, which we can use to give people a sense for elevation without using anything more than color on the DEM. We'll also look at different ways to stretch our rasters with symbology, and I'll show you how to do a vector field raster and then display the resolution of the raster in the table of contents, and then a way to change the interpolation in the display. So it'll be quite a lot, but we should be able to get it in. First, let's do that hypsometric tinting. So if I right click and go to properties, this is a symbology effect. And first I'm going to click use hill shade effect and click apply. And what we'll notice if I close this out and zoom in is I do get a little bit of that hill shade effect. It illuminates my raster in such a way that I have a sense for which sides slope which way. This is all for illustration and it's not for analysis, but for making quick maps or just for getting a sense of the landscape, this can be really helpful. Now let's change the color of the raster so that it gives me that hypsometric tinting. I'm going to right click on here and turn it off of graphics view and take a look at them by name. And let's select elevation number 1, and it shows me the colors there, and now I can take it off of graphic view since I've found it. And yeah, let's use that one rather than elevation 2. So I'll click apply, and now I get the effect of both the hill shade and hypsometric tinting. This isn't perfect, and in fact for a map I was going to publish, I would probably not do it exactly this way. I would generate a hill shade using a geoprocessing tool and then hypsometrically tint the digital elevation model and overlay it on top of the hill shade with some transparency. For those of you who took the first course, you did this in one of the assignments there. But still, it's an interesting way to display the raster. Now, part of what's bugging me about this and how it looks is how jagged everything is. Everything looks kind of like it came out of an old printer or something like that. And I can clean that up by changing the interpolation that ArcGIS is using in the background. We'll talk a little bit more about what interpolation is and how you could do it on actual data sets for analysis purposes later in this course. But for now, know that it's a way of kind of inferring a higher resolution raster from a lower resolution raster. And in fact, let's zoom in a little more so we could see what's going on here. And it's giving us all these really jagged edges and all these artifacts from the way that it's handling this hill shade effect. So if I right click and go to properties again, and now I go to the display tab, under resample during display using, it sets nearest neighbor by default, which is a good way to be a default, but let's set it to cubic convolution. And if I click apply, it cleans it up tremendously. And if I zoom out again, I don't get those jagged edges on my ridges. So what's going on here? With nearest neighbor interpolation, if we try to display a raster at a higher resolution than it actually is stored at, it just picks the nearest cell to display in each pixel. So right now we're zoomed in beyond the natural resolution of the raster. So each pixel on my screen needs to figure out which pixel of the raster it should be representing, and it just shows the nearest raster pixel to wherever it's at. With cubic convolution, it uses a much more complicated algorithm to figure out which raster pixel to display, and for continuous data like a digital elevation model, it is much more eye-pleasing. So for display purposes, it's a good algorithm to use. For data analysis, you should be very careful with it. But on that display tab, we're only doing display, not analysis, so it's safe to use here for the most part. Okay, so let's take a look at making a vector field. And what I'm trying to create is maybe I want to see at a glance both the slope and the direction of the hill. So I want to use a set of arrows to do that. And maybe where the slope is represented by how long the arrow is, so that's how steep it is, and the direction of the arrow represents which way the hill faces. So let's turn off our digital elevation model and we need to create a new surface called an aspect raster, which defines which way a hill faces. And we can do that in Spatial Analyst using the surface tool set and using the aspect tool. And all I have to provide is an input digital elevation model, and it's going to give me an aspect raster back. So I'll call it Valmeyer aspect, and it's running in the bottom. and I get this back, and it's kind of technicolory, very bright. But now that I have it, I can turn my slope raster into a vector field. And I'll right click on it, go to properties, and go to the symbology tab, and I'll have a vector field option up here. And so I have magnitude, which is the size of the arrow, and direction, which is which way the arrow faces. And I'm going to need to set the direction component separately. So in the drop down, in the main part here, I don't see the aspect raster. But if I go to the more here, and then I select from auxiliary data, Valmeyer aspect shows up, and I can click OK. And I'll just leave it as it is for now, and click apply. And then click OK. And what's happening right now is that the aspect raster is drawing on top. But if I turn it off, I can now see my slope and direction field here. Let's put the digital elevation model below it and turn it back on. And now if we zoom in, and then let's set the digital elevation model back to gray here so we can see a little better. Now we can see all these arrows telling us exactly how steep and which way the slope is facing. This technique is much more commonly used for things like wind or groundwater, things where you have fluids like air or water moving around on the landscape. What I'm using it for now is just a demonstration, but it's not necessarily a common use case for it. Okay, let's turn off our slope here. And what if I wanted to know visually how different this top of this hill is? It's all very bright, and so I can't really see what's going on here. This happens sometimes with rasters like a flow accumulation raster or some others that you might have where there's a huge range between the bottom and the top, and most of the values are skewed to one side of the raster. You can't really visually see what's happening on the raster. Well, I can have it set my stretch automatically based upon how I'm viewing it. So if I go to the symbology tab for a stretched renderer, I can scroll down, and where it says statistics from each raster dataset, which means it gets the stretch for the raster from the whole dataset itself, I can change it to from current display extent and click OK. And as I look around the raster, it's going to update that. And I still have a low spot on my raster, so the stretch is the dark is down here and light is up here. But if I move that out of the display, there's another one here, but let's zoom in. And now I get more detail. It constantly changes the stretch as I zoom in and out. Similarly, out on the floodplain here, there's not a whole lot of detail because there are much higher areas around. But if I end up with just the floodplain, just like I did, all of a sudden I can see all the detail on the floodplain. And I can see that there are probably some artifacts maybe in the raster down here. And as I zoom around, I can start to see the surface in much more detail. So that's getting the statistics, the stretch, from what I'm currently looking at right now. And the last thing I want to talk about is that after we've zoomed in like this, sometimes it's hard to know whether or not we're viewing the raster beyond its resolution. That is, whether 1 pixel in the raster is matching up to 1 pixel on my screen or more or less. Well, if I go to the raster properties again, and I go to the display tab, I can select display raster resolution in table of contents here. And if I click OK, under the raster, we should get a resolution indicator here saying how many pixels on the screen equal how many pixels in the raster. Now it should update as I zoom in and out, but it looks like it's not right now. There's something wrong with it. So that's a feature that usually works. It was working just a moment ago, so I'm not totally sure what's going on, but know that that's a feature that's potentially available to you, where as I zoom in and out, it should tell me the ratio of raster pixels on my screen to the raster pixels in the raster dataset itself. Okay, that's it for this lecture. In this lecture, we covered a lot of ground. We looked at hill shade effects and hypsometric tinting. We looked at changing the display interpolation to cubic convolution to see the raster a little better. We looked at vector fields with slope and aspect rasters and the potential to use those for other situations. We also changed how ArcGIS gathers the statistics for the raster dataset in order to better show us the variation in the landscape. And then finally, I showed you an apparently broken feature that displays the raster resolution as it compares with the screen resolution. These are all just little tools to help you in your analysis and data viewing, but I think that they're pretty useful to know about, and I hope they help. Okay, see you next time.